Hello, and welcome to Rectangular Coordinate System and Graphing Lines. There's another lecture on Rectangular Coordinate System that I did. You can find it on my YouTube channel. It's 1508, probably section 1.1, Rectangular Coordinate System. My name's Tuesday J. Johnson. I'm an assistant professor at Doña Ana Community College and a lecturer at the University of Texas, El Paso. This particular lecture is geared towards the intermediate algebra class at Doña Ana Community College, Math 120, also at NMSU. Chapter 3 of the XYZ text by Turner McKeague is called Linear Equations in Two Variables and Functions, and section 3.1 is the Rectangular Coordinate System and Graphing Lines. So let's start with a definition. A pair of numbers enclosed in parentheses and separated by a comma, such as parentheses -2, 1, close parentheses, is called an ordered pair of numbers. The first number in the pair is called the x-coordinate of the ordered pair, and the second number is called the y-coordinate. Therefore, for the ordered pair -2, 1, the x-coordinate's -2 and the y-coordinate's 1. The rectangular coordinate system with which we use these ordered pairs is based on two number lines. We have a number line going horizontally with the positive values going up to the right, negative values decreasing to the left. And then another number line that's perpendicular. So it's a vertical number line, and positive values are going up, negative numbers are going down. And these ordered pairs that we have describe first the x position and then the y position, always in reference to the origin, the starting point of 0, 0. So a point 4, -3 would be right 4 units, down 3 units, the negative indicating down. In general, this horizontal axis, this horizontal number line is called the x-axis, and the vertical number line is called the y-axis. Horizontal alphabetically comes before vertical, x comes before y, so they go together. The quadrants, probably not as I would have labeled them if I came up with this system, but I didn't. So how does it go? It goes based on the rising sun, right? The sun rises in the east, quadrant 1 to high noon, sets in the west, quadrant 2, and then comes back around, quadrant 3, quadrant 4 to reset. Now, I know as well as you do that the sun does not revolve around the earth, but as we view it in our location, the sun rises in the east and sets in the west. So let's graph some ordered pairs on the rectangular coordinate system given. If we have a equals a 1, 2, I'm going to start at 0, 0 and go 1 over, 2 up, and I have a point 1, 2 for a. I can use a different color here. 0, -3. So my x value is 0. I don't go right, I don't go left, I just go down 3 units. And put a dot. For -4, -1, I'm going to go to the left 4 units. It's 2, 3, 4, and down 1. Negative direction to the left, negative direction down. And 3, 1/4. So I'll go to the right 3. And then that's not down a quarter, that's up a quarter. And it's really hard sometimes to get it exactly right at a quarter. So if I say that's a quarter, we're going to believe it for now. Sometimes you have to use your imagination that you hit the right spot when you're graphing. But we need to be able to go the other way as well. So if I'm writing the coordinates of each point, let's make this a little bigger so I can get some detail on here. If I'm writing the coordinates of each point, I'm going to start with A. A has moved over to the right 2. Right 2 is a positive 2. And it has gone up 3 units. Up is in the positive direction. For B, left 1, so -1. And then up 1, so that's a positive 1 for Y. C has gone to the left 5, and then down 5. Left and down, both being negative. D has gone to the right 1, so a positive 1, and then down 5, a -5 for Y value. E has not moved left nor right, so it's an X value of 0. And then up 1, so a positive 1 for y. F has moved to the left 4 from the origin, always in reference to the origin. The origin right here where they meet, 0, 0. And then F has not moved up, F has not moved down, F is at a nice little 0 for the y value. What about G? Hasn't moved left or right, it did move down 2. So we can find the coordinates of the points based on how they've moved left or right from the origin, followed by up or down. Let's go with the definition. A linear equation in two variables is any equation that can be expressed in the form ax plus by equals c. Now, can be, not must be. It might be that we have to rearrange some of the values and we have to put it in the right form, but it could be expressed as ax plus by equals c, and we'll have a special name for that equation in a couple of lectures. A, b, and c are real numbers, where a could be 0 as long as b is not, or b could be 0 as long as a is not. You must have either the x or the y, or else we don't call it a linear equation. If we take ax plus by equals c and isolate the y value, the equation will have the form y equals mx plus b. This is one of our critical formulas for linear equations. We're going to use it repeatedly. So how do we graph these? For each of the following equations, we're going to find 3 ordered pairs that satisfy the equation and then use them to graph the line. I'm given the equation y equals negative 4x. So this tells us whatever x values we choose, we're going to multiply them by negative 4, and that's going to be the y value that goes with them. So I get to choose my x values, any values I want. I'm going to use x equals negative 1, 0, and 1. My form for my equation is negative 4 times x. So I think of that as negative 4 times something. It's a skeleton form. It shows the structure. And then instead of x, I have my parentheses and I replace my value. So negative 4 times negative 1 is positive 4. My point. When x is 0, negative 4 times 0 is 0. I have another point on the graph. And when x is 1, negative 4 times 1 is negative 4 for my third point on the graph. If you draw straight lines like I do, you might want to use a straight edge in order to help yourself out. Use some imagination, and my lines are pretty straight too. If y equals 2x minus 5, I'm going to use the same 3 x values. Why not? They're the easy ones. The structure of my formula is 2 times something minus 5. So I put in my somethings. These are values that I chose independently because I felt like it, because they're easy values to choose. You could use your favorite number of 17 or maybe your favorite number of negative 3.1, whatever you're feeling. I like to keep it simple. Put negative 1 in for x, I'll have 2 times negative 1, which is a negative 2. Minus 5 gives me a negative 7. When I choose x equals 0, 2 times 0 is 0. Minus 5 gives me a negative 5. And when I use 1, x value of 1, 2 times 1 is 2, minus 5 is negative 3. So I'll have the point 1 comma negative 3. Draw the line and there you go. So in this case, y equals a negative 3 halves x plus 2. Negative 3 halves times something plus 2 is our form. But I didn't choose my standard negative 1, 0, and 1 this time. Because I saw this fraction, and I saw a denominator of 2, I said to myself, hey, how about I use even numbers here, and 0, so that when I multiply, I don't have to deal with fractions. So that's exactly what I did. So when x is negative 1, I'll have negative 3 halves times a negative 2, and then plus 2. The negative 3 halves times negative 2 is positive 3. 3 plus 2 makes 5. So at negative 2, I have a y value of 5. Negative 2, 5. Let's put a point in there. When x is 0, negative 3 halves times 0 is 0 plus 2. So I'll have a point 0, comma 2. When x is 2, negative 3 halves times 2 is negative 3. Negative 3 plus 2 is negative 1. So I'll have the point 2, comma, negative 1. And this is always the frightening part for me. I can't draw a straight line to save my life. But imagine, if you will, that doesn't move at all. It's a nice straight line. Imagination's a great thing. Let's go with it. Now that we have some specific lines to the origin, and looking at example 1 that we just did, y equals negative 4x, that's a great example of this. The graph of any equation of the form y equals mx, where there's no b listed, will always be a line passing through the origin and through the point 1 comma m. M being the coefficient of x. So if I wanted to graph the line y equals a negative 2x, I know there's a point at the origin, and the m value is negative 2, so I know a second point 1 comma negative 2. With any two lines, I can draw a linear graph, a line. Intercepts. An x-intercept of the graph of an equation is the x-coordinate of a point where the graph intersects the x-axis. The y-intercept of the graph of an equation is the y-coordinate of a point where the graph intersects the y-axis. For an intercept, the other coordinate's always 0. And why is that? Let's move this up here a little bit. If I draw a graph, let's go back to black. Remember my x-coordinate, or excuse me, my x-axis is horizontal. And anytime I'm on the x-axis, right, any point here on the x-axis, notice the height is 0. But if I have any point on the y-axis, notice my x is always 0. So for any intercept at all, the other coordinate is always 0. Good thing to keep in mind in order to solve. So let's find some intercepts for each graph, write them as ordered pairs. Then we're going to use those to help us sketch the graph. We call this the intercept method. Sometimes I'll call it Tuesday's cover-up method, and I'll try to show you how with my pointer here, but we'll see. See if I can make that any bigger. If I have 2x plus 4y equals 8, I know the x-intercept has a y value of 0. A y value of 0, I'm going to put it a 0 in for y. So I'll have 2x plus 4 times 0 equals 8. But what is 4 times 0? It's almost I'm covering this up. And when I cover it up, what am I left with? I'm left with 2x equals 8. If 2x equals 8, I know x equals 4. It tells me x is 4. I assumed y was 0 because I was looking at an intercept. The y-intercept always has an x value of 0. Y-intercept, x value of 0, I'm going to put a 0 in for x. I'm going to cover that up because that's going to be 0. And I end up with the equation of 4y equals 8. Divide both sides by 4, y equals 2. That tells me y is 2 and x is 0. So I have the point 0, comma 2, the point 4, comma 0, and I can join them with a straight line. Let's do it again. For y minus x equals 5, if y is equal to 0, then minus x equals 5, and we'll multiply both sides by a negative 1 to get x equals negative 5. If y is, the y-intercept has an x value of 0, so if I put 0 in for x, I'll get y equals 5. Y equals 5, and draw the line to connect them. The intercepts method, or Tuesday's cover-up method, whichever one is 0, we cover it up and we solve what remains. A great way for graphing linear functions if they're in standard form. But if they're not in standard form, like y equals 2x minus 4, we have a little bit more work to do. The y-intercept is still straightforward. We'll still put just x equals 0. 2 times 0 is 0. Minus 4, I'll get y equals negative 4 for a y-intercept. Your b value is always going to be your y-intercept, and we'll talk about that more in a minute. X-intercept is when y is 0. So I have a little bit of manipulation to do with this equation. I'm going to add 4 to both sides. If 4 equals 2x, I'm going to divide both sides by 2. X equals 2. I didn't write them as ordered pairs. I can't follow instructions. I'm pretty bad at that, as a matter of fact. 2, comma 0, and 0, comma negative 4, my ordered pairs, so that I can graph them. Alright, now I took this directly from the book. I'm going to give credit where credit is due. Remember, this is an XYZ text from Turner and McKeague. And it's a little fact from geometry, some special equations in their graphs. For the equations below, m, a, and b are real numbers. So if we have an equation of the form y equals mx, we already discussed how that's going to have a point on the origin, and then its tilt is going to be decided by m, because 1 comma m is going to be another point on the graph. So special line y equals mx always goes to the origin. If we have a vertical line, it's always going to be x equals a. An equation, always an equation for a vertical line. It always has the form x equals, because it doesn't matter what y is. Always x is just equal to this a. Y could be anything. Whereas a horizontal line, x could be anything, but y is always the value b. So horizontal and vertical lines have more simplistic equations. Vertical, x equals a. Horizontal, y equals b. So if we graph some of these, if we graph x equals 3, I go to 3, I pretend that I can actually hit 3. I know it's going to be a vertical line, so I also pretend I can draw a vertical line. Use your imagination, people. For y equals -2, I find the y value of -2, draw a horizontal line, yet again pretending I can draw a straight line, and I label it appropriately, y equals -2. If it's not given to me as x equals or y equals, I could take x plus 4 equals 0 and subtract 4 from both sides. That gives me x equals -4, and that's a much better line, I must say. If y minus 1 equals 0, I can add 1 to both sides. When I get y equals 1, I know it's going to be a horizontal line. No x involved means it's going to be horizontal. Whereas here in blue, no y involved, it's going to be vertical. Y equals 1, x equals -4. That's the rectangular coordinates and graphing linear equations. Thanks for listening.